So, now that we've finished Module 3 of the A-Level Physics course, it's time for us to start trying some more synoptic questions and developing our problem-solving skills a bit more. Now, this can be really challenging, but it's a skill it needs practicing. It can be learned and improved like any other skill. So, let's have a little think about what we need to do, why we need to do it, and how we're going to go about it, and what that means in terms of our next steps on the course. So, being able to problem solve is one of the things that makes physics so valued by employers and universities and so on in life. And the reason that they think it's valuable for us to have is because in order to be good at physics, we have to have developed logic, determination, resilience and mathematical ability to solve these challenging problems. If we gave up every time something was tricky, we'd never get anything done. Now, these skills are really valuable, and this is why people really like students that have got physics qualifications. But like any skills, in order to develop them, we need to practice. There's no other way to go about it. We have to do practice questions, and the more questions we answer, the better we will get at developing these skills here. And different people start with different levels of these skills, but whatever level you start at, the more you practice, the better these skills are going to get. Now, when we practice something, what we're trying to do, if we think about practicing a sport or something else like that, what we're trying to do is to practice routine so that they become automatic and second nature to us. Now, the routines that we want to put in place for problem solving, we've already discussed quite a lot in class, and they're the ones that have been set out by the Isaac Physics problem solving book that we've been talking about. So let's just go over them again, go over why we do them and what we're hoping to achieve with them. First of all, in our questions, when we're reading them, when we're reading the problem, we look for keywords. Then we're going to draw a diagram. We're going to then identify the concepts that we need to apply to solve the situation. We're going to do all of our working in symbols, like all the rearranging and so on. And then finally at the end, we check the dimensions of our solution and add in the numbers. Now, quite often, I have to persuade people to take up this routine, which I always find astonishing. But just to go over each step and why we're doing it, why it helps us. Keywords, we're looking for words like frictionless, no air resistance, light, inextensible, things like this. These keywords simplify the situation for us. And if this situation is simplified, it's going to be easier to solve. They're really, really important. We don't want to miss them. So we're going to take note of them. We're going to highlight them. We're going to mark them in the question. Second of all, drawing the diagram. By drawing a diagram, we are summarising what we understand of the question. We're going to label it with symbols because we're working in symbols all the way down to stage 5. That's all in symbols. And this is a really, really important step in us interpreting the wording of a question or a problem and then starting to figure out how to solve it. Then the third bit that's about to get more challenging now with synoptic problems is we have to identify which concepts in the course we're going to be applying to solve the situation. So it's all about identifying the relevant concepts. Now, if you were just learning about moments and you were given a problem on moments, this part of the routine is much, much easier because you know you have to apply moments. But if you're not told what concept you need to apply, or if you have to apply more than one concept together across different parts of the course, this is where our problem solving gets trickier, but also much more rewarding. Working in symbols. We stay in symbols throughout the whole bit here, even when we're rearranging the equations, because it makes it much easier for us to spot mistakes that we've made in any of our working. And then finally, right at the end, once all that has been done, we can check the dimensions in terms of checking that the units on both sides of an equation are balanced, and we can check the numbers that are going in. So we're checking units and dimensions. These 5 stages have been suggested to help us understand and analyse a problem. They're really important they might not all be necessary for every single type of A-level question that you're doing at the moment, but they are all necessary to answer the more challenging and the most challenging questions we get at the end of the A-level course. So we want to put them into practice and get them as an automatic routine now, before we can't progress any further without them. Now over here, when we were talking about the skills that everybody thinks physicists have that are amazing, one of them was mathematical ability. So it might be worth us just, going over the mathematical skills that we're going to need to have to, solve these problems. We're going to need to know our SI base units. We need to know our prefixes and be able to manipulate them confidently. We need to be able to work in standard form confidently and accurately. We need to be able to manipulate scalars, add them together and subtract them, and we need to be able to manipulate vectors, so that's adding the vectors, subtracting vectors, and resolving a vector into its component parts. If you don't feel confident with any of those things, or while you're practicing these problems you find actually you're not quite sure about your prefixes, you need to pause, go back, make sure those are learnt before you carry on further. Now, one of the things that we like to do a lot in teaching is to help you get from where you are now to where you want to be. And one of the ways that we do that, we call it scaffolding. So the idea is that we're not asking you to make one massive jump. We're going to scaffold it into smaller steps. So let's have a look at the steps that we're going to take and the things we can do to break this down so it's less intimidating. First of all, time. When we are practicing initially these problems, we're going to do it without any time constraints. Even if in an entire homework period we only get one question done, but we get it done really, really well, showing all of the 5 steps of this routine and we solve it, that is really, really good. So take all the time pressure off yourself while we're practicing these skills. Don't try and do mark a minute, remove the time pressure. Secondly, you can make things open books. That means you can look things up, you can look up equations, you can remind yourself of concepts if you want to. This can also take a bit of pressure off while you are developing these skills. And then thirdly, difficulty. We are not going to go straight into solving the most challenging and complex questions that you'll see at A-level straight away. We're going to start with easier questions, develop these routines, practice these skills, and then ramp up the difficulty as we get more and more confident with these skills. So bear these 3 scaffolds in mind and think about which one you can adjust for you to make sure that you're making good progress in developing and practicing your skills. So there is the overview. These are the things to bear in mind in terms of why we want to practice synoptic problem solving, what we need to be doing and what we need to be bearing in mind. And I want you to go back to this page, look at these things. I need you to be trying to show logic, determination, resilience and your mathematical ability when we're practicing these really challenging questions, especially as we're not all in the classroom together. You need to make sure that you know the more practice you do, the better you're going to get. You need to make sure that your mathematical skills are where they need to be. And you must be putting this 5-step routine into place, even if you don't think for this particular question all 5 steps are necessary. So, things to do next. First of all, we're going to practice questions. That's our next job. All of them, I would like you to be showing the 5-step routine. If I cannot see the 5-step routine in your working, I'm going to be asking you to go back and change it. I want you, as far as possible, and I know it's challenging given that we're not in lessons together, to try and be resilient when the problems get challenging. Finding it difficult is not a sign that you're doing badly, it's a sign that you're learning and getting better. I have made you a problem-solving booklet. You're each going to have your own copy available through the Google Classroom, and your working and annotation for me to give you feedback on should be going in there. But as I've said on the Google Classroom, there are lots of different ways that you could add that working into that booklet, but that's where you'll find the problems that we're going to be solving. And as you're working through the problems in that booklet, any skill areas that come up that need extra work, please just pause and go back and do those. So it might be you start the first problem and actually I can't recall my prefixes, I need to go and sort this out, and you actually pause and you go away and learn them and then you come back That's brilliant, that's perfect, that's exactly what we want to be doing. So go and find your problem solving booklet and let's get started.